definition of a force is any interaction that, when unopposed, will change the motion of an object. So a certain amount of force can cause any object that contains a mass to change its velocity or direction. When using a water squirter, you put the front of the object in some type of liquid. Then you pull back on the blue handle, and this causes suction and results in the fluid to be drawn into the two tubes. The plastic yellow pumps are now behind the tubes containing the water. The handle is then pushed forward and force is applied. Given the object has mass, we can assume that mass is a positive number. By pushing the tubes, you create an interaction that changes the object's motion, creating force. This applied force is also offset by the force of friction, resulting in F net. This F net is then divided by the mass of the object in order to find the acceleration. Therefore, the force originally applied, which is the Fa, results in acceleration. An example of this is football players pushing a sled. Say there is a 943 Newton linebacker pushing a 158 kilogram sled. This linebacker applies 1,980 newtons to a sled, and there is 200 newtons of friction. Quick bonus. When using a water squirter, work and power is also involved. Work is the product of force times distance. So when there is a movement in the direction of force, work is involved. Power is the rate at which work is done. It is the amount of work done in a given amount of time. So if I'm pushing the handles forward very slowly, there would be less power than if I push the handles very quickly. This also affects the acceleration and how far water travels. And to continue the topic of water traveling, let's pass this to Lavender.
When a water gun is being held at a height of 1 above ground level, a student who is holding the gun at 55-degree incline at a constant speed, there is a projectile motion acting on this motion. The projectile motion is a form of motion experienced by an object or projectile near the ground and moves along the curve under the action of gravity. We can measure the horizontal distance, which is the dx, the vertical distance, which is the max height, and the dy. So we can use the formula 2AD equals vi squared minus vi squared to solve for vi. Then use the cosine and the sine theta to find the vi and vx. Experience that related to the projectile motion is the fountain. For example, there is a fountain above the river. The horizontal distance is 2 meters, and the height is 3 meters, like here. The angle between the water and the river is 45 degrees. So the question is, what is the VI, the VIX, and the VIY? Here's the note list. And we can note acceleration is negative 9.8 meters per second squared. And the VF is 0.
Today is a water gun. Potential energy is shown to the water gun by the pressure of pulling back on the gun. Doing this is building up force, and pushing the gun back into place is also a great amount of force. The force is being used to squirt the water out. Depending on how far you want the water to go, the more potential energy you would want to build up. That also goes for the gathering of the water. The more water you want to put in the gun, the more force you will put upon the gun as well. The formula that goes along with potential energy is PE equals mg.
Real-world experience that can relate to potential energy is someone swimming on a swim. In this situation, the person is 47 kilograms, and the highest that they go is 28 meters. The equation for potential energy is PEG equals mgh. The mass was 47, the g is 9.8, and the height is 28, which altogether equals 12,896 newtons.
The toy has two major parts due to how it moves and essential for it to work. There is the part that applies pressure, which is similar to a plunger. It also sucks the water in when pulling the handles and pushes the water out. Then there's the part that holds the water and lets the plunger part of the gun push water through it. The gun also includes small holes and the water is pushed through. There's almost no air that is let into the tubes, which means that there could be no suction.